with this problem. Let's look at problem C. Now, problem C may look different, but it's actually not. If you actually turn our negative exponents into, well, remember that these negative exponents turn into tiny little fractions. So x to the negative 1 would turn into an x to the first on the denominator. What's hidden on top would be a 1. Well, 1 over x to the first is just a 1 over x. Well, keep going. So the next piece you would go after would be your y to the negative 1, which would turn into 1 over y. Now you do the same thing to the bottom. Well, going on to the bottom, we have an x to the negative second, which would actually come down to the bottom as an x to the positive second, again with a hidden 1 on top, so that's 1 over x squared. Keep on going. And the last piece here, the y to the negative second would turn into 1 over y squared for the same reason. So again, you'd run into the same problem. You'd want to get a common denominator. Well, on top, a good common denominator would be just an xy. And on the bottom, you've got 2 x's and 2 y's, so you need to have x squared, y squared as your common denominator for the bottom. Well, on your first piece, for your first fraction, let's see, you already have an x, but you want an xy. So how do you get the x to turn into an xy? Well, you just need to multiply the top and the bottom by a y. So that'd give you a y on top. On the second fraction, on top you already have the y. Again, you want an xy, so you'd multiply the top and the bottom by, let's say, an x. Let's look at the bottom now. On the bottom, we have an x squared on the first fraction, but we'd want the common denominator of x squared, y squared. So to get that, we'd multiply by a y squared on the top and the bottom. On the second fraction, we have the y squared, but again, we want an x squared, y squared, so we'd multiply by an x squared on the top and the bottom. So what this would now give me at this point in the problem is I now have a y minus x on top over an xy because they have a common denominator. Just putting that entire top piece together would give me that fraction. Then looking at the bottom piece would give me, let's see, the bottom piece would give me a y squared minus x squared all over x squared, y squared. Again, that's your bottom piece. That's what we got by putting those two together because they already have a common denominator. Well, then you do have, it looks messy, but you do have one big fraction on top and one big fraction on the bottom that we're dividing. So you could do keep, change, flip now. Keeping the first fraction would leave that as a y minus x over xy. It would change your division into multiplication just like before, but it would flip that last fraction, so it'd become x squared, y squared over y squared minus x squared. Your only question would be is once you hit this point when you get multiplication, is there anything that factors? And there is only one thing that factors, and it's this y squared minus x squared because you have a difference of 2 squares. So this difference of 2 squares would factor out as a y minus x and a y plus x. So we could just replace the x squared, y squared with the y minus x and y plus x. Then the question would be, does anything cancel? Well, notice what would happen is you'd have a y minus x and another y minus x on the top and the bottom, so those two would cancel out. What also you can cancel out is, notice you've got some x's on the top and x's on the bottom. I can cancel out one of the x's on the bottom with one of the two on the top. And I can cancel out one of those y's on the bottom with one of the y's on the top. So what's left over when we're all done? Well, we have an x and a y that's on top, that's left over. And let's see, on the bottom, we have a y plus x. And that's all we can do because the x and the y here are not the same. On top we have an x that's alone and a y that's alone, but on the bottom we have a y plus x, which means the x and y are attached with a plus sign. So you can't do anything beyond this. We are all done, and this is our final answer.